Connect to a router. Cisco device routers and switches typically interconnect many devices. For this reason, these devices have several types of ports and interfaces that are used to connect to the device. So, for example, is a Cisco 1941 router backplane includes the connection and ports described. So, the LAN and WAN interfaces. The connection on the Cisco router can be grouped into two categories: in-band routers interfaces and management ports. So, the router boot up process. There are three major phases to the boot up process. So the number one is perform the post and load the bootstrap program. Second is locate the Cisco iOS software. Third one is locate and load the startup configuration file or enter setup mode. The basic switch configuration step. Cisco routers and Cisco switches have many similarities. They support similar operating system, support similar command structural, and support many of the same commands. In addition, both devices have identical initial configuration step when implemented in a network. Configure router interfaces. So, for routers to be reachable, the in-band router interfaces must be configured. There are many different types of interfaces available in Cisco routers. So, in this example, the Cisco 1941 router is equipped with the 2 gigabit Ethernet interfaces and the serial 1 interfaces card. Verify interface configuration. There are several commands that can be used to verify interface configuration. The most useful of this is the show IP interface brief command. The output generated display all interfaces, their IPv4 addresses, and their current status. The default gateway for a host. For an end device to communicate over the network, it must be configured with the correct IP address information, including the default gateway address. The default gateway is only used when the host wants to send packet to the device on another network. The default gateway address is generally the router interface address attached to the local network of the host. The IP address of the host devices and the router interface addresses must be in the same network. Default gateway for a switch. Typically, a workgroup switch that interconnects client's computer is the layer 3. The layer 2. Such as layer 2 switch does not require an IP address to function properly. However, if you wish to connect the switch and administratively manage it over multiple networks, you will need to configure the SVI with the IPv4 address, subnet mask, and default gateway address. So that's all for this chapter number 6, which is the network layer. And thank you. Hi everyone, I'm back with a new video, and for this video, we're going to summarize this given chapter, which is the chapter 6, which is the network layer summary. So let's start. So the network layer, the network application and the service on one end devices can communicate with application and services running and on another end device. How is this data communicated across the network in an efficient way? So the protocol of the OSI model network layer specify addressing and process that enable transport layer data to be packed and transported. So, the network layer. The network layer or the OSI layer 3 provides the service to allow the devices to exchange data across the network. Uh, to accomplish this end-to-end transport, the network layer uses four basic processes. The addressing and device, encapsulation, routing, and the de-encapsulation. The network layer protocol. There are several network layer protocol in existence. However, as shown in the figure, there are only two network layer protocol that are commonly implemented. It is the Internet Protocol version 4 and the Protocol version Internet Protocol version 6, the IPv4 and the IPv6. Encapsulating IP. IP encapsulates the transport layer segment or other data by adding an IP header. This header is used to deliver the packet to the destination host. The IP header remains the same from the time the packet leaves the source host until it arrives at the destination host. The characteristics of IP. IP was designed as a protocol with low overhead. It provides only the function that necessary to deliver packet from the source to the destination over an interconnected system of networks. IP connectionless. IP is connectionless, meaning that no dedicated end-to-end connection is created before data is sent. Connectionless communication is conceptually similar to sending a letter to someone without notifying the recipient in advance. IP media independent. IP operates independent of the media that carry the data at lower layers of the protocol stack. IP packet can be communicated as electronic signal over copper cable, as optical signal over fiber, and wireless as radio signals. The IPv4 packet header. So, the IPv4 packet header consists of the field containing important information about the packet. These fields contain binary numbers which are examined by the layer 3 process. The binary values of each field identify the various settings of the IP packet. Limitation of the IPv4. Through the years, IPv4 has been updated to address new challenges. However, even with challenges, IPv4 still has three major issues, which is the IP address depletion, the internet routing table expansion, and the lack of end-to-end connectivity. So, introducing the IPv6. In early 1990s, the Internet Engineer Task Force, the IETF, grew concerned about the issues with IPv4 and began to look for a replacement. This activity led to the development of the IP version 6 or the IPv6. It overcomes the limitation of the IPv4 and is a powerful enhancement with a feature that is better suited current and foreseeable network demands. So, encapsulating the IPv6. One of the major design improvements of the IPv6 over the IPv4 is the simplified IPv6 header. So for instance, the IPv4 header consists of 20 octets or the 60 bytes if the option field is used, and the 12 basic header fields, not include the option field and the padding field. As highlighted, sa IPv6, some fields have remained the same, some fields have change name and position, and some IPv4 fields are no longer required. The IPv6 packet header. The field in the IPv6 packet header include version. This field contain 4-bit binary value set, the traffic class. This 8-bit field is equivalent to the IPv4 differentiated service. The flow label. This is 20-bit field suggested that all packets with the same flow label receive the same type of the handling by routers. Payload length. 16-bit. The 16-bit field indicates the length of the data portion. The next header, this is the 8-bit field equivalent to the IPv4 protocol field. The hop limit, the 8-bit field replaces the IPv4 TTL field, the source IPv6 address, and the destination IPv6 address. The host forwarding decision. Another role for the network layer is to direct packet between hosts. A host can send a packet to itself, local host, and the remote host. Default gateway. The default gateway is the network device that can route traffic to other networks. It is the router that can route traffic out of the local network. Using the default gateway. A host routing table will typically include the default gateway. The host receives the IPv6 address of the default gateway either dynamically from Dynamic Host Configuration Protocol or configured manually. The host routing table. So host, the route print or the netstat/r command can be used to display the host routing table. Both commands generate the same output. The output may seem overwhelming at first, but it's fairly simple to understand. The router packet forwarding decision. When a host sends the packet to another host, it will use its routing table to determine where to send the packet. If the destination host is on the remote network, the packet is forwarded to the default gateway. Directly connected routing table entries. When a router interface is configured with an IPv4 address, a subnet mask is activated. The following two routing tables entries are automatically created. The next, hop address. When a packet destined for a remote network arrives at the router, the router matches the destination network to the route. In the routing table, if a match is found, the router forwards the packet to the next hop address out of the identified interface. So, the anatomy of the router. A router is a computer. So, there are many types of infrastructure router available. In fact, Cisco routers are designed to address the needs of many different types of businesses and networks, for such as branch, the WAN, and the service provider. Router memory. A router has access a volatile or non-volatile memory storage. Volatile memory requires continual power to maintain its information. When the router is powered down or restarted, the content is erased and lost. Non-volatile memory retains its information even when a device is rebooted. Connect to a router.